Today we're going to be learning how to solve systems by elimination without common coefficients. So what we need to do is multiply one or both of the equations by some number to create matching opposite coefficients. And I'm going to explain what that means in a second, but please be free to pause this movie at any time, rewind it, fast forward it, whatever you need to do. Okay, yesterday we talked about how we can eliminate variables because we're solving using elimination if we have common coefficients. But if I'm looking here, my coefficients in front of this first equation, x, it's just 1, and then the coefficient on the bottom is 2, top is for the y is 3, and then the bottom equation for y is -7, so I don't have common coefficients. But with my knowledge of how to solve equations and make sure that this equal sign is still true, I can multiply one of the equations by a number or both of the equations by a number to create those coefficients that I can eliminate. So I'm going to look at that first equation, and the reason why I want to look at the first equation is because I see that if I multiply this x right here by -2, I know that these are going to have opposite common coefficients. And so I'm going to do that. Now, remember, whatever I do to one side, I have to do to the other. So I'm going to multiply both sides of that equation by -2, and I'm just going to rewrite it out to the side. So you end up with 2 times x, which is 2x, 2 times 3y, which is 6y, and those should be negative, sorry, and then 6 times -2, which is -12. And then all I'm going to do is rewrite that second equation. I wrote that first equation in red so you can see what I changed. And now I can eliminate a variable because I have opposite common coefficients here. So -2 plus 2 gives me my 0 pair that I'm looking for, and I end up with a -13y equals -13. And then I divide by -13 on both sides, and I end up with y is equal to 1. So I can still eliminate even if I don't see those common coefficients because I can make those common coefficients. And then I'm going to go ahead and do the next one in blue. I'm just going to plug that y back in that I just found. So instead of writing in y there, I'm going to write in 1. So x plus 3 equals 6. If I subtract 3 on both sides, x gives me 3. So my solution to this system would be 3, 1. Okay, so again, if we're given two equations in standard form, our best bet sometimes is to eliminate. So you need to make the decision on which variable you should eliminate. So if I'm looking at my x's right here, I see if I multiply 2 times 4, I get to 8, but I'm not going to get to 9. So I want something a little bit easier than that. So I'm going to look at the second variable there, my y. And on this bottom one, if I multiply both sides by a -3, which is pretty easy here, then I'll have common opposite coefficients here for my y's, and I'll be able to eliminate those. So I'm going to rewrite that first equation because I didn't do anything to it. And then I will distribute that -3 for that second equation. And I'm writing it in red so you can see what I changed. So -3 times 2x is -6x. -3 times y is just -3y. And then I end up with -15. Now it's important to remember here, the reason why I'm manipulating this equation here, this bottom one or the top one, is because I want to eliminate variables. And we know that anything we do on one side, whether I multiply it by 9 million or -3, all I have to do is do the exact same thing on the other side, and I'll keep this equation true. So that's why I can just multiply things by both sides of that equation, because I need to change it in a way where I can eliminate. So I end up with 3x, zeroes out, equals -3. And if I divide both sides by 3, I get -1. And from there, I'm just going to do it in blue so you can see what I'm doing. I'm going to pick the equation with smaller numbers. Remember, I'm plugging in the variable that I just solved for, which is -1. And then add y, and that equals 5. So I end up with -2 plus y equals 5, or y equals 7. So my ordered pair here is -1, 7. Okay, we're going to jump to 6. So the answers to 3, 4, and 5, if you try them on your own, are on the website. So go ahead and check there if you need extra help. But I'm going to continue with some of the problems on the back. So again, I need to make a decision on which one or what I can multiply by, which equation to get two or one of my variables to eliminate. So for this first equation here, I see that if I multiply it by -2 on both sides, I'm going to be able to eliminate those x's, and I'll also eliminate those y's, and we'll kind of see what happens here. So I end up with -6x minus 2y equals -4. And then that second equation was 6x plus 2y equals 4. So when I combine them, I end up with 0 and 0 equals 0. So remember, if we end up with something weird like this, you just have to ask yourself the question, is this true? And by this, I mean this equal sign. So is 0 equal to 0? Yes, it is. So I have infinite solutions for this system, which means that these lines are the same line. Okay, so jumping forward to number 8 here. If I look, there's nothing I can multiply by 3 to get into 5, and nothing I can multiply by 3 to get to 4. So in the beginning, we talked about how we can multiply one or both equations by some number to create matching opposite coefficients. So we're going to have to multiply both equations here. So it's kind of easy here. I just got to choose one that I want to make negative, but if you look at your coefficients, that's what you're going to end up multiplying by, unless you have a lower common multiple. So I have 3x and 3y. I know that if I multiply both of these by -4, and then also in the second equation, multiply everything by 3, that my y's are going to cancel. And so I'm going to rewrite the first one in red so you can see what I'm doing. -4x times 3, -4 times 3x is -12x. And then I got minus 12y. And then that's equal to -36. And for that second equation, I have 15x plus 12y. And that's equal to 30. And then I would go ahead and just combine. So -12x plus 15x, I'm left with 3x plus 0, because that cancels out, equals -6. So if I divide 3 on both sides, x becomes -2. And then I just choose one of these to plug it into. And remember, I'm replacing that x with -2. So I end up with -6 plus 3y equals 9, and I'll add 6 to both sides, which leaves me with 15, and then y is equal to 5. So my answer or solution to this system would be -2, 5. Okay, so for number 9, it's a similar situation to number 8. I can't multiply anything by 5 to get to 7, and I can't multiply anything by 9 to get to 10. So that means I'm going to have to multiply both equations by some number in order to eliminate a variable. So I'm just going to look at these first two here and choose 5 and 7. One of them has to be negative so that I can cancel. So for this first one, I'm going to multiply both sides by -7. And on that second one, I'll multiply both sides by 5. So I'll go ahead and rewrite both of those equations, doing it in those colors so you can see what I'm doing. I end up with -35x minus 63y equals 70. Remember, negative times a negative gives me a positive. And then when I distribute my 5 to that second equation, and I end up with 35x plus 50y equals -5. And then I'll just go ahead and combine this like normal. So 35 minus 35 is 0. I end up with a -13y equals 65. And that 65 is positive here. So both sides I'll divide by -13, and y ends up giving me -5. So if I have y equals to -5, then I just choose one of my equations to plug that y into. I'm going to go ahead and plug it into the first one. So 9 times -5 equals -10. So when I combine -5 and 9, I get 45, and I'd add 45 to both sides. 5x is 35. I divide both sides by 5, and I get x equals 7. So the solution to this system is 7, -5.